So we are currently in the graphic extension for BASIC. So we're if you remember, we're extending BASIC to allow us to draw lines, circles and all that jazz. Now when I left the last stream on the 14th, look at that, 14th, seems like an age ago. Anyway, it didn't work and it took me another 2 hours to figure it out. And it turned out that I mistyped a variable and I'd put an incorrect instruction in. So just to show you that it's working, here we go. Right, I think I still have this on there. Yes, I do. Right, so here we go. Here we go. So that's now drawing the lines. Now the line drawing function is one of the key functions of this because we'll use this line drawing function to do a lot of things. Drawing circles and all that jazz. But it's a little bit slow. Now, when I was a kid, when I wrote this, and I wrote this, I thought it was imperative to use the basic functions within your machine code. So if you remember back then, when I typed this all in, we was using, where is it? Here, we're using the floating point accumulators of BASIC, both 1 and 2. So we have to convert to a floating point and then convert back to an integer. We have to move a floating point to memory and then move it back. We do the divide in BASIC. And the problem is the way it stands now is for each point across whichever axis we're running across, for each point, we multiply that point by our ratio. Every point is done a divide. So you could have 320 divides if you do a full line across the screen. Now that is inefficient because, well, when I was a kid, you know, I was trying to be clever. Pythagoras and all that jazz. You know, that's how you worked out these points, by dividing the ratio. Now, there's another way of doing it because it doesn't matter which way we're going, because what we do is we need another pen. Here we go. Doesn't matter which way we go because we always pick where the line is going to go. So if we do that, we're always going to pick the y-axis as the one we run through because it's the bigger difference than the x-axis, which is just this bit here. And vice versa, if we do that, the x-axis is the biggest difference than the y-axis. So we'll always be running across one of the axes. And I explained that, I think, when I did my presentation. Ugh. I think. Do you know I missed a slide when I did it? I missed a slide. Anyway, this one. So this is basically showing it. If we have a line, the green line from here to here, then we would run along the x-axis because the difference of x is bigger than the difference in y. But if we use this one, the difference in y is bigger than the difference in x. And so we don't have to do the multiplication. We don't have to do it. Yeah, so the divide, we don't have to do the divide and then the multiply. So we divide to get the ratio and then we multiply that ratio by the point. Now, we don't need to do that. Now, when I was 16, I thought I was being clever, which technically I was. But maturity and age has taught me that we can do things faster. Now, I did a dividing divide by routine for Neptune lander. I did a divide by routine that didn't do the remainder. So when you divide 22 over 7, for example, it's 3 remainder 1. Yeah. I don't want that. I want it to come out as a decimal fraction. So the way to do it is you've got to divide it properly. So this is a routine that I wrote, and it's a 16-bit divider. And what it does, it takes a high and low byte number, high and low byte divider, and it returns back a 3-byte result. So it's high, low, fraction. And this is the routine I used to understand binary fractions when I did Neptune lander. And I thought we could use this routine to divide the dx by the dy to give us that ratio, which would give us a 3-byte binary fraction, instead of using the floating point accumulators in BASIC. And then as we run across whichever axis we're going, we initialize our start point as the xy of the starter position, and then after that we just add our binary fraction to it. So eventually it starts going up and up and up and up and up. So each one. So we're not doing any multiplication, we're just doing bog standard machine code adding. So the other thing I was wanting to do is, remember we was talking about this was going to be a imitation cartridge, so we've got to code it like we are that it's going to be burnt onto a ROM. And one of the things a ROM can't do is alter its location. Now when I did this when I was, how old, 16, 17, whatever, I was doing self-modifying code. So for example, for this routine we're sending in the set carry and we're sending in the subtract with carry, and that was going to be put on the x-axis calculator routine. So down here is the x-axis calculator routine, and you know, we would be putting it on the draw x, where's that, draw x, here we go, draw x for y. So basically we'd be changing that to set carry, that to subtract, and that to subtract. And same with the y, that would be set carry, subtract, and no, it's only one on the y. But the problem is you can't do that when it's a ROM, right? You can't do that. You can't do self-modifying code because it won't work. So there's two things I'm going to do in this stream, right? So we're going to modify this draw. We're going to modify this draw to make it, one, incredibly quick, and two, to make it not use self-modifying code, because we need to make it cartridge friendly. So what I'm going to do is I'm going to make a copy of this. We're going to bring this into our divide routine into the system and then try and incorporate it in, which I've got to figure out how to do, seeing as this was written 18 months ago, because I've just released my last Neptune lander video today. I'm not doing any more, bad enough. So first things first, have we got a utilities function? Have we got a utilities function? No, we haven't. Right. Let's see where we, so, okay, Okay, we'll see where we can fit this in. Right, let's add a new inc file, utilities. Right, so where's my headers? Here we go. List of a library of functions that will be used throughout the code. Here we go. So the first one is going to be divide, 16-bit divide. This function works out the binary fraction of two 16-bit numbers. Right then, let's copy this baby. Right, we'll ignore the watches, we'll copy that lot, and then we'll figure out which 0 pages we're going to be using. So we will call this divide 16-bit. That'll do. So now we need to identify some 0-page variables. So let's get our mapping book up. Is it in here still? No, it isn't. Oh, I've been doing my Starship Voyager in Minecraft. They're the pictures. I've actually got the outline already done. I might let you look at it in a bit. Right, so let's see what 0-page file values can we use without screwing up BASIC. So you've got to remember, we're going to be using just for graphics. So we can't mess around with any 0 pages for array setting or line setting or for next. What's that? Serial evaluation. I think we're using that already. 71 and 72. Where's our memory? I need to shut some of this stuff down. Let's close that down. Don't need that. We could use that. 14 and 15. No, that's part of the cruncher. Right, let's see. Have I got any memory? Oh, it's all here, isn't it? Okay, that's why it's all here. So we're using F7 and C1. Let's see. Would they be enough? C1, what's C1? Location pointers, beginning address of area in RAM that's currently being loaded or saved. Well, yeah, we can use that. During the tape load or save, the first block, we could use C3 and C4 as well. Yes. We could use that. In fact, we will. Right, so that's given us some 0 pages, and we need that lot in here. So I will do that. Then that. So this is allocating the memory. Oops, this is allocating the memory so we can work all this stuff out. That goes there. Oh, I've just noticed the keyboard ain't on. Hello, MVD. Right, keyboard's on. You should be able to see what I'm doing now. Ooh. Ooh, that's wrong. Number, that's number. That's number high, and that's divisor. It's better. Well, that's not going to work. Leave it where it is. Right. So now we've done this. So the inputs are number to be divided by, oh, not to be divided, yeah it is, isn't it? To be divided by, no. Whatever. And we have got divisor is the number to divide by. Right, so initialize that, initialize that, initialize that. Okay, so we're initializing everything. That's fine. No, that's not fine, because they're the two that we're going to use. So that's my example. So the example is store the number in working. So straight away we need to do LDA number, store it in working. Oh, it's number high. So that's basically setting up, which is what we do here, and then we run through the divider. So basically you divide the working one by 2. If what pops out is a carry, then you add it to the result. You multiply it into the result and then subtract the divide. Well, it's all here. It all works. So instead of that, we do it. So the result will be in result, fraction, result, and result high. So all we need to do is set the divider number and the divisor, and then call this. So that resets all that lot. We don't need that anymore. Set up working, and then run through the loop. Yep, that works. Now how we're going to incorporate it, let's copy this, clone. And so this is the new draw command. There we go. So where's the draw command? There. Let's close that down and we will disable. We will exclude from project. There we go. Right, so that's now CVM will not look at that now at all. So basically we're going to do the same as before, where we worked out the first things is are our numbers correct? Hello Stacey. Are our numbers correct? The next thing is, does it blow our limits? You know, are they bigger than the limits? And then this then tests if x1 is greater than x2. Now we need to do this. We need to work this out. So basically what happens is there's two routines, one for the x and one for the y. And depending on which is bigger, x1 or x2, if x1 is bigger than x2, then it's adding. If x2 is bigger than x1, then it's subtracting. So we end up with two routines for the x, and so we have two routines for the y. So we end up with 4 routines. Currently there's only 2 because we're doing self-modifying code. So what we need to do now is to change those 2 routines into 4 routines and then figure out the mechanism to fire that routine. So yeah, gonna be so I think we should do that first and then just check that we ain't broke it. So these are our 2 routines here. So draw x, draw y. And then the other one is, so this is draw x start, that's the one. Draw y start, and then the other one is draw x start, I think. There, draw x start. But the actual routines we change are these. This one here, that one. So that's the x. Right, where's my routines that does the modifying? Here we go. So draw work out x from y. Draw work out y from x. Here we go. Let's draw work out x from y and draw work out y from x. No, that's y from y. Okay, so it's that one there for that one. Draw work out x from y. Okay. X from x, x from y. So there's 2 routines we're having to modify. Right, let's have a look at draw work out x for y. That's here. Work out y. Okay. So basically we need to create, this routine needs to be doubled. Yeah. And work out y from y. Work out y from y. And this one as well, that needs to be doubled. And then we've got the same with the x, which is work out y from x and work out x from x. They're the 2 routines that are going to have to be doubled. So what I was thinking of was having a status byte that tells us exactly how we are going to run the code. So we would set the status of the byte and then we'd evaluate the byte and do it here. So so we've got we've got two routines that have got two ways of doing it, so that's 4 on both the X and the Y. So I think we should be able to use 1 byte. We'll use it here. So this would be the drawing status. No. Execution driver. So basically that's going to have the high 4 nibble will be for the Y and the low 4 nibble will be for the X. So let's see if we can work this out. So we got draw X on from Y. Let's go back. Work out X. Hang on, we're doing Y at the moment. So we've got work out X from Y and work out Y from Y. Okay. So X from Y and Y from Y. Okay, so we don't need to use the 4. What am I thinking? I can do it this way. So we got X from Y and Y from Y, X from X and Y from X. So they're the two bits. So we're going to have 4 bits that we're not bothered about, and these are the options. So 0 equals add and 1 equals subtract. So if there's a 1 in there, that means that this routine needs to go into add mode, and if there's a 0 in there, that means it needs to go into subtract mode. Yeah, I think that'll work. Add equals subtract. So let's put a comment directly above it. So we're talking 3, 2, 1, 0. So they're the bits. Yep. So 0 is add, 1 is subtract. So that's all we need to do. So here, when we're working out, right here, like for example, let's find the first one, which will be here, prepare X calculation. So the X calculation is a subtract. So that means prepare X calculation. Let's see if we can find that. Find. Where's find? There, 215. So it's setting both X and Y to be in subtract mode. So that's subtract. So if we use our philosophy, so that's saying change the byte in X from Y, X from Y, and change the byte in X from X. Yeah, so it's definitely these two. So we'd set those two into subtract mode, so both those bits would be set to subtract. And seeing as we're here, calculation, so yeah, so that's exactly the same thing. Right. So it's dead simple. We're not mixing at all. So let's rem out what they were before. Here we go. Got a rem somewhere here. There we go. That's it. So effectively, we're going LDA #% and it's the last two bits is the X, isn't it? XX, XY, yeah, last two bits. So it's going to be 00, 00, 00, 0011. Store it. In fact, let's do this properly. LDA that and it with, we're not bothered about that, reserve, keep those, blank those out, or it with that, store it back. To that. Yeah, that'll do. So that's preparing the X. This is preparing the X as well. Okay. Rem that out. Put that in. This time, this is add. So blanking it out. Don't need to worry it, because 0 is add, 1 is subtract, and that's the X, prepare the X. Okay, now we're on the Y, so we'll put that in, rem this out, but this time we want to blank out the Y, but we keep the X, and subtract his ones. Hey Faze, how you doing? So we've got one more to do, which is here, which is the add. So we just forget the ones, we just clear it out. So that's now set our flag. So when we I have got the book. So we need now to evaluate those at the appropriate times. So these are the workouts. So this is work out Y from X and X from X. Let's just have a look at the prepare just to make sure. Work out X from Y. Right, so the first one says Y from X. Draw, work out Y from X. Y65. You know, I bet that's the Why did I do 65? I'm looping through. I'm looping through the X. So I'm looping through the X. I must be doing the multiply somewhere. Where am I doing the multiply? Ah, JSR draw, work out, new point. There we go. So we're doing XX divided by YY. Does that need a hash? No. 65 is what is the memory address when you convert back to integers. So I think we need to rework this. No. We're accessing the basic floating points directly, which floating point 1 is 65, 66, 67, 68, I think. Let's go back. Yeah. There's floating point, where is it? There it is. So 65 is the, but this is used for when you're converting back into a 16-bit number. So that's floating point 1. So that's where 65 is coming from. So basically what we're doing in this, because we're drawing along the x-axis, we're multiplying x by the divisor to work out y, yeah? And because y is only a single byte, that means the value will be in 65. So what I'm trying to do is I'm trying to take the value that you've got at the moment, add that very little bit. Oh, shut up. Who cares? So, this draw routine. So the X draw routine needs to be... Okay. The X draw needs to be recalculated. So we're drawing along the x-axis. So we load the difference, we compare it with 0. It doesn't matter now, comparing with 0, it doesn't really matter anymore. Set floating point to 0. Yeah, well, we don't need to do that anymore. Yeah, we don't need to do that anymore. Start drawing, start x-axis drawing. So that's there. Yeah, I know. The optimization for this will come later, mate. Yeah, I know. And it's there as well, I know. But this was when I was done as a kid, so optimizing will come later. Okay, so what we're going to do is we're going to rewrite this whole function to allow us to perform the X and the Y in tandem. Yeah. So we're drawing along. So drawing along the x-axis means we start at we start at y. That's the delta. Starting at, no, they're not starting at the delta. Using the delta to work out the point, and we're not doing that. So draw x-axis loop. So LDY, the x low, x high. Okay. So there's two ways of doing it. We're going to be decreasing x and adding y, or decreasing x and decreasing y. Is the x could be going so we got the two ways. If we're going backwards, we start at x2, going forward start at x1. Okay. Draw delta. So that's working out the deltas. Going to be drawing along the x-axis if the x delta is more than the... Right, so draw along the x-axis. So we are taking the delta. Is it 0? Well, we don't need to do that, so we can jump straight to working out right, XX low and XX high are the are points that we're going to use to draw, I think. XL low, XL high, X low, XL low. Okay. How do we define what starting point is? Here we go. So we're loading 0 in XL low and XL high, 64 and 65. Then we're loading XL low, XL high. Then we are adding 1. Work out new point. Right, accumulator's high, Y is low.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, 6502 Kebab, welcome. Thank you for following. Just trying to work out the logistics of drawing a line in without using any basic. Because I'm using basic functions all over the place. Okay, so we need to, right, let's start drawing, that's the start there. So we need to test because we need to, this is where we're going to, this XL low and XL high are our points where we place, where is it? There. So we are using XL low and XL high. Got it. Okay. I think I've got it. Cool. 2 weeks and you forget all your code. So we do X low and X high. So we must do a swapper. Let's see if I can find where the swapper is. Right, you're here. That's the delta. So we must do a swap somewhere. Good morning, Jason. You had your coffee yet? Good man, good man. X1 low. Yeah, that's right. X1 low, because X1 low would be the start point, or for adding, so we'd be adding to X1 low and then subtracting from X1 low. Right, okay. So I don't need to worry which way we're going as long as we're doing it. So we need to run through X delta and yeah, we need to run through X delta. XL low and XL high will be the units, but we're either subtracting it or adding it. Right, okay. So let's do this. Start drawing the x-axis. Okay, so our XL low and XL high will represent our delta that we're going to be running through. Right. And then we add the delta, or subtract the delta, from x1. So x1 minus subtract 1 would be that way, yeah. x1 would be that way. And that way, yeah. Okay. That's our delta. We're not using floating points anymore, so we don't need to do that. So we need to work out let's do the workout now, add it, flip round. Yeah, okay. So, so when we're running along the x-axis, we're going to be doing increments or minus increments, whichever it is. But for the y-axis, we're going to be adding to it. So I think there's a comp YL. Is there a YL? Yes. So, and that YL will be it's Y1, isn't it? We start at Y1 and add or subtract our divider. Right, we need a divider. Have I got a divider in here? $65 was in that one. What was the other one? Here we go. 65 and 64. Okay, so we need some variable space. So we need the, but we can use the result. Yeah, we can use the result. We use those. Okay. So is it? I've been seeing if mine's on there. I've been checking every day. I thought it would have been there. Look at that. Oh, it's there, look. Hey, I'm on CSDB. Oh, they didn't show any of the screen then, did they? I presume that's me. So you're on here, are you? Which game? Oh, Toxic Frenzy, yeah. Yeah, it's there, look. Came out on the Christmas day. I saw that. Why do I see ads? I have no idea what you talk about there. Because you get ads on this website. Yeah, so there's me. So yeah, we're famous. Someone found our games noteworthy to put a crack on there. I didn't... Would have been nice to have seen a screenshot, but there we go. Anyway, yeah, I saw Toxic Frenzy was on there. As well as being a published gamer, I'm now a cracked one. So, draw X, where are we starting? Right. So that's going to be our run through. Yeah, I'd rather be called a crack gamer than a crackpot. Right, so we need now to load. We need to now load Y, was it XL I said, wasn't it? So we store, so we load, let's load Y1, store it in com YL, so that's our starting point. That's our starting point for 6. Right, now we're in the loop, so we need to do the test. So we need to, come on, thank you. So load. Oh, I've lost where I was. There we go. So we are loading this. And we're currently doing the X. So it's this bit here, the Y. So this is what we're doing now. So it's bit 1. So we'll load that. We will AND it with that. And branch if not equal to draw X, oh no, this is draw work out Y on X. But this is going to be, if it's not equal to, that means it's a 1. So this is going to be subtract. So if it's equal to, then it's adding. So then we're loading com YL, add in result fraction. Let's just try and work this out. The only time that this would fail is if it's on a 45-degree angle, where Y is adding 1 pixel as well as the X. So what we need to do is we need to prime this carry. But if you're subtracting 1, yeah, we need to so if we load result, and then because the result, it'll only ever be 1. It's either 1 or less than 1. So 1. So we need to do a roll right to stick it on the in the carry flag, and then we add the fraction. So if it's 1 and the fraction will be 0, yeah, that'll do it. So that's updated YL. So we need to jump somewhere. And now we take that and we do exactly the same. But this time we do subtract. So if we're going to subtract 1, the carry needs to be clear, doesn't it? So if there's 1, we set the carry. If the carry's clear, it subtracts 1. Right. So what we need to do here is we need to make sure if the result's 1, it'll come out 0. If the result's 0, it'll come out 1. So that's effectively setting the carry, and then we subtract. Right, so we are now work out x on x. So that's where we're going. So this, let's work out y on x add. So that's working out the y on the x, but it's an add because y1 would have been smaller. And this is working out y on x subtract because y1 would have been bigger than y2. So if it's not equal to, that means there's a 1 left in the accumulator, so it's subtract. Right, so we now need to do the same thing for the x. But this time we are looking at that one. If it's not equal, if it is equal, this is work out x on x add. Now in this particular instance we're only adding or subtracting 1 because we're running across the x-axis. So LDA com what? Have I got slots? Hey! I've got slots. Right, so inc com XL high, and then we bypass around it if it's not. So basically, because we're just on the x-axis, we're just running across it every pixel. We're just adding one to the counter, and then we need to do the jump, and then we come here and do that, and it's exactly the same, but this time it's set carry, subtract 1. So if the carry is set, no, it's clear. So if the carry is clear, now if the carry is set, that means we didn't take a carry. That's all right. Yep. And then we decrement this. Let's just make sure I've got this right. I haven't set. Yeah, my little head, my voice in my head was going, oh, it's wrong, it's wrong. That's it. Set XL low and XL high to the points. Subtract 1. Sorted. So now we need to do the drawing because we've worked out where it is. So this is here. So that's there. So we would go to that, and this would go straight into it. No. Let's do that and put that there. So we are loading YL, store it in com Y. Don't need that. Don't need that either. So that's basically doing that. Draw, place it, draw the lot. Then, see that's doing the increase there, but we're not doing that. We need the counter for the delta. Need the counter for the delta. Need to be able to stop it. And I'm not sure what was we using here, XL low and XL high, but we've repurposed that. What other ones have I got? Ooh, we could use those. We could use those. So COM XX low and COM XXY. So where do I, here we go. XX, XX. Right, so that's our counter. So XX, XX. So XXI compare with delta, XX low compare with delta. Right, so if it's not equal, go back to X loop, which is here. Yep, that'll work. Evening. Evening, Axel. That will work. So we don't need this. We don't need that. Don't need that. Draw along y-axis, which is the same as draw along x-axis, I think. Yep, there it is. So effectively we're doing the same thing as this. So we're doing the same thing as this, but now for the y-axis. So we'll just move that out of the way. Paste that in, and we'll change all the variables. And right, so that's where we're doing. So on the y-axis, we are now concentrating on these two bits. So this is the y. So this is working out y on y. So if it's that and that, yeah, y on y. So we're not loading the result because we're running through y, so y is just going to be a simple clear carry, load that, add one, store it. So y on x is the next one. No, x on y, isn't it? That's it. So y on y subtract is the same, but this time we set carry and subtract 1. Well, I've not set it up, have I? No. Not set it up like a Wally. Was there a YY? Was there a YY? Yes. Don't need that because that is the result. So we've done the Y sub and the Y add sub. Then we jump to YY sub. So this is work out X on Y. So X on Y is that one. Bit 3. Yeah, so that's that one. So work out X on Y. So this is work out X on Y sub. And this is X on Y add. Right, this is where we have to do all the jiggery biggery pokery. Now we don't need to worry about pre-configuring because X is a 2-byte anyway. So we load Y, load result fraction. So we're adding the result fraction, storing it back in there. But this time we then load in com XL high. ADC result, and then storing it back. Don't need that. Don't need that. So we go to work out X from Y. So the sub is an exact copy of that, but the other way around. So set carry, subtract with carry, subtract with carry. So we load com YL into Y, that lot into that, place the dot, then we increase YY. Don't need that. Load YY, compare it with YD, go back to Y loop. It's gonna be interesting. Let's get rid of the stuff that we don't need now. Loads the difference, evaluates the difference of Y. Which way are we going? So that's coming here. Oh, we don't need that. 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 There. That's where we're starting. Draw along the x-axis. All right, mate. See you later. Draw along the x-axis, draw along the y-axis. that is there. So we can get rid of that one, put that there. And that's doing that. But is it? That's placing a dot. That's the x-axis. Draw along the y-axis. That's the one. Yeah, that's the one. Right, let's see if this works. I doubt if it will, but let's see if it works. Oh, poo. Press the wrong key. Press the wrong key. Is there an error? So it can't find that. Work out y on x sub. That's there. Oh, hang on. Have we got two of them? Duplicate label. 173. I bet the other one's further down, isn't it? Work out y on y. Work out x on y. Oh, is that it? Right. Y on x then. But that's already taken. Oh, I've got my labels all screwed up. Make them more. Right, drawing the x-axis. So we're working out the y on the x sub. So this is y on x. That's right. Work out x on x. Work out y on x. Yeah. So this one should be work out y on y. Yeah. Work out y on y. Work out. Ooh. That's got to be x on y. But I think I've used x on y, haven't I? No. Work out x on y. So this is x on y sub. Yeah. X on y add. Draw, work out x from y. That's right. Work out y on x. Ooh, hang on. That's x on y. Right, that should do it. Oh, duplicate label? What are you talking about? But that's not included in the project. Aha. Right, let's load my test file in. That doesn't look any... That didn't feel any quicker or slower. That should have been lightning quick. Oh, have I been modifying the wrong one? Oh, you're joking me. I've been modifying the wrong one. Yeah, been modifying the wrong one. It's alright, easily solved. Let's get rid of that. Modified the wrong one. So now we need to sort this lot out. Duplicate. Work out X from Y. But that should be right. Have I? Work out X from Y axis. Work out Y from X axis. Where's the duplicate label in there? It's that one, 248. No? Line 365. Oh, hang on. I'll still left all that in, didn't I? Aha! Right, F5. Oh, hit the wrong one again. Still got that one. 173. So we're working out Y on X. 173. Work out Y on X sub. But that's X on X sub, isn't it? We're getting there, getting there, getting there, getting there. Come on. Oh. So I assume it doesn't like the spaces. Let's see if there's any more. Yeah, it doesn't like the spaces, does it? this is going to blow up terribly. All right. Yep, that works. That works. So we need to now work out the ratio, because that's what's missing now. We need to do the divide. We need to do the divide now. So it's working out. I was expecting it to be completely all over, but because the because we didn't work out the result, it's defaulted to 0, so it's just given a straight line. So now we need to work out the divide. So there we go, it's the deltas. Jumped draw delta calc. So what we need to do now is, if x is bigger than y, we divide y by x. If y is bigger than x, then we divide x by, divide. Get it right, John. If x is bigger than y, then we need to divide y by x. If y is bigger than x, then we need to divide x by y. Yeah. So when we come in to draw along x-axis, we already know that our x delta was the bigger one. So what we need to do is we need to load the deltas into the setup. So load com xd low, store it in number. No, it's divisor. Load com xd high, store it in divisor +1. So basically, because we're running along the x-axis, we're now doing y divided by x. So we've just put the divide by x in, now we've just got to put the y in. So LDA com y delta, store it into number. LDA #0, store it in number +1. Because y is only a single byte. So that'll work out the divisor, and then we need to run JSR the routine. And so for the y-axis, it's the opposite way round. So draw along the y-axis. So it's the opposite way round. So we'll just swap this lot over, put that there, put that there. So now it's not number. Number goes there. Divisor is now the one. because we're now doing x divided by y, because y is the bigger number. Do the 16-bit divide, then all should be good, he says confidently. Now we need to include utilities. Now I'm going to include it in there, and then we'll check to make sure we haven't blown the 8800 part. In fact, I'm not. We'll put it there. Utilities. I wish I had faith in me, mate, I tell you. Have I spelt that right? Yep. Right, here goes nothing. So we got the straight lines because everything... Ooh, what was that? That was a big boom. Let's try that again. F5. Oh, it did it that time. Right. Come on. Puh. It does the line. It does the first line. It does the first line. Okay. Right. Yeah, it does the first line. Right, so it does the first line. But it blows up. So that must be something to do with the divider. Must be something to do with the divider, that is. Let's see if we can stick a breakpoint in this. Get rid of that. Draw. Where's draw? Right, we'll put a breakpoint there. And see what we get out of the 16-bit. So we'll have to make note of the numbers. We'll make note of the numbers. Oops. Right, so where's a bit of paper? So result is O2D7. And so fraction is D6 and high is D8. Right. So let's see what we're getting out of that. We'll have to I think it was the third line which is longer on the X, I think. So X delta low is O2B7 and high is B8. What's the Y delta? BC. Y delta is BC. O2BC. And then we can work out what the number should be. Okay. Right. So it was, yeah, Y was slower, so it's running across the X-axis, that is. So it's going to break. I thought it would have broke. Didn't break. Oh, I didn't run it in debug, did I? Pants. Let's run it in debug. Divide by 0, could be. That's why I want to see where it breaks. Oh, that's not going to find it, is it? That's not. We'll type it in. 10 graphic. 20 draw. 10, 10 to 100, 100. See if that still works. Run. Yes. Right. 30 draw. 10, 10 to 100, 30. But it didn't break, did it? The breakpoints have not been set. Right, let's see if we can get this thing to break. I need to find where to put the breakpoint. Where's the dump? There it is. Right, so where do I want the breakpoint? Let's point. Here we go. Draw. Draw X. That's what I want. Draw X. So there, I want the breakpoint to be at 8986. 8986. Just minimize that. There. So that's after it's done the divide. But we'll put a breakpoint before it because we can check the cut. Can check. Right, here we go. So this is the first one, right? Why is that broken there? Oh, it's because I've set that into it. And you can't get rid of it anymore. Go away. Clear. There we go. So now we have broken for the first line. Let's get a better view of it. Control. No. That's it. Right. O2 B7. O2 B7. 0, 1, 2, 3, 4, 5, 6, 7. So that's the low, so that's 5A. The next one is high, which is 0, 0. BC, 7, 8, 9, A, B, C is 5A. Right. So let's put our breakpoint there. F11. Right, that's done the divide, so our result will be in D7. D6, D7. 0, 1, 2, 3, 4, 5, 6. So the fraction is equal to 0, 1, 0. That's why the first line works, and it draws the line. Now in the second one where we are where basically it should draw a line from there to about here. So X is the big and Y is the small. So we need to check now. So the X delta is B7, 2B7. So 0, 1, 2, 3, 4, 5, 6, 7. That's the low. So that's right. So 5A is 100. Yep. That's the delta. So the delta for Y is BC. So 7, 8, 9, A, B, C is 14. Which is right. Because 14 is equal to 20. Because we start at 10 and finish at 30. So 5A is 90, isn't it? Yeah. Right then. Let's see if it goes through the divide routine. Here we go. It did. Right, so what's the result? So D7. 0, 1, 2, 3, 4, 5, 6. Here we go. So this is the fraction. It's at 38. Then we've got 0, 0. Right, 0, 0. So it's worked out 38. So 38. So 38 is 0, 0, 1, 0, 0, 1, 1, 0. So that's a half, a quarter. So we've got an eighth in there. A 16th, 32, 64th, and a 1/28th. So whatever that works out to. So let's work this out. So we've got open bracket. Let's clear this. Back into scientific mode. Right. So we have 1/8 plus 16, 32, 64th, 1/64th plus 1/128th. Undo, back. Undo. Oh, God, Bennett. Clear. 1/8 plus 1/128. 64th plus 128. So that comes out at 0.1484. So effectively it's 20 divided by 90. That's not the same. Oh well, we'll carry on. We'll see why it's blowing a fuse. So our running numbers are XL. Here we go, XL low. So they're O2 BC. So XL low is O2 BD. XL high is BC, BE, and our COM X, that's that one there, is O2 BF. Right, so we're in the bird park. We know what's going on. So O2 BD, that's down here. BF, BE, BD. So these are the three numbers that should start getting changed. So let's go through it. We've got the divide. Let's see what happens. So that's doing an add. So it's loading D7. Loading D7, which is a 1. No it ain't. No it ain't. It's 0. We roll it in. That should clear the carry, which it does. Add it to BF. So BF is here. BF is there. OA. So that's the starting point. 10. Ah, that's where it's going wrong. That is where it's going wrong. Fadoodle. Poo. Right. Okay. Now, I know what's going on. What's happening is, and I made this stupid mistake in Neptune Lander as well. I remember it. Ugh. We're adding a fraction to the low byte, when really we need another fraction. Fadoodle. What complete plank. Right, so I need a com underscore XL. Oh, why is the XL frac? And that equals that plus 1. And com YL frac. Oh, can't believe I made the same mistake again. Right, so in our drawing, so where we're doing the adding and stuff, so this is doing YL, so this is the fraction, yeah? This is the fraction.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, thanks, Gar PPA. Right, so we are not loading the result. We are loading the fraction. So let's do this right. CLC, load the fraction, add to com YL frac. Did I call it frac? Yeah, all one word. YL frac. Right, I need to initialize these as well because they need to be set to 0. So we will use this. So store that in there. Store that in there. XL frac. They need to be zeros. Add it to the fraction, store it in the fraction. In fact, we'll do that. Better. And then we load com YL, add result, store it in com YL. Grab that, do the subtract. So we don't need all that clever mechanics. Set, subtract, subtract. We don't need all this rubbish. Right, and then we need to do exactly the same. We're adding 1 to x. Yep. So we'll do the same thing here. Let's grab them two. Where's 0? Yes, there it is. Let's use that, store it there. Right, so the working out here is the same as before. So we're adding 1 to the y, so that's right. Subtracting 1 to the y. So this is the x that we need to do now. So the x is LDA com underscore XL frac ADC result frac store it there. Get rid of that. Then we are loading XL low. Add the result, store it in low, and this is result high. Can't believe I made the same mistake again. Sec SDC SDC SDC. Right, here goes nothing. We have an error. And of course we don't see it. Ooh. It's too far. Okay. Undo, undo. Control Y. Oh, come on. Okay, let you off. Oh. Right. So it's definitely branch carry clear. So that's carry set. So jump. That sorts that out. So he's complaining about that one as well. So we will do branch if equal to exit. And that will be jump. Right then, let's see. Come on. Get in there! Look how fast that was. I gotta run that again. Oh, that is fast. That is fast. Oh, me likey, me likey. Right, so there we go. We have rewritten the draw to not use any basic floating point functions whatsoever. So we're not using the divide, we're not using the multiply, because before we was using the multiply on every point, so it was multiplying on every point. So we've got our own dividing system, a fraction divider, which works out the difference for each pixel movement, and then we add that difference for every pixel. So if it was the Y, it'd be slowly working its way up, and that's what we're getting. All right, let's put another one in. Let's do 10 190 to 110. Let's do that. So 150, draw x10, 190 to x is 100, comma 10. Run. Oh, hang on. Have I got that wrong? Oh. Let's put 100 in there for the moment. Yeah, I got it wrong. So I want it coming this way. So 10, 190. That's up there. Oops. So 10, 190, that's up the top, and then going down, so x2 should be 10, 10, 10. No, 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 no. No, because x is going up, y is going down. See, there's a problem there. It's going up, it's going the wrong way. So that's going up. So that's going from 10, 100 to 100, 10. That's going the wrong way. That's definitely going the wrong way. Surely it's going the wrong way. Let's 10, 10, 200, 320. So 10, 1, 10, 190. Well, 10, 100 is there. And then 10 is there. Oh, 100. So we go to 100, yeah, and 10. So it's definitely going back. It's definitely going down. So it should be increasing x, but decreasing y. And I think what's happening is it's not. I think it's adding to y. Yeah. So we need to check our limit, our calculations. So that's drawing on the x-axis. Let's make it a bit more subtler. 15010. That is going to make it an elongated line. There we go. So it's still definitely going the wrong way, but it's definitely the x-axis. The x-axis is... So this lot's working. That lot working. So the points here. Oh, the origin point's down here. Yeah. So these are the ones that are up here. So 200 to 100. So that's x going backwards, and y 190 to 100. So that is y going backwards. So that's x and y going backwards. X and y going backwards, going backwards. So this is a combination of x going up and y going down. That is what's going up. That's what we're having a problem with, where we're running across the x-axis, and that's going in a positive. The x is going positive, and the y is coming negative. It's going down. So that's what we need to check. Right. So that's what we need to test. So let's run this in debugger and find out where the test is, and then we can so debug program. It hasn't changed, I don't think. So we're checking the deltas, and it's drawing along the y-axis. Right, so it's here. This is where we are. So 8 DA. So that's where we need to start. We need to start here. So we've checked, and now we're figuring out which is bigger and which is not bigger. Yeah? So 8 DA. So we'll handwrite it in, graphic 20, draw 10, 100 to 100, 10. So we'll run it. So we should end up with the line going that way. Yes, there we go. Right, so we need to put a breakpoint at 8 DA. There. Let's just check that's in the right place. Load O2B2. O2B2. Yep, there it is. Right. Let's run. Let's find out what's going on. So we're loading B2. So that's X1. Get this up. So we're loading X1 high and comparing it with X2 high. So X1 high is 0, comparing it with O2B4, which is 1, 2, 3, 4, which is there. Oh no, 0, 1, 2, 3, 4. So that's the same, branch if equal. Now we're doing B1, which is OA, against 3, which is 64. Right, so that is saying that it is, so it's working out the deltas. So if I go down here, so it's done that one. So that's gone to this one here, 88EE. No, it hasn't. It's gone to 890E, which is down here. Oh yeah, it bypassed all that, didn't it? 890E, so it's doing this. So it's saying X1 is less than X2. Okay. So that's, so that is set in, right, O2E1. Make sure we know that, we've got that on there. O2E1 is there, OC, right. So it's doing the deltas, so this is working out the deltas. Now this is doing the mask, so it's OC. So it's saying that both of them, that's not right. That's where we're going wrong. It's saying that both of them are additions. Oh, subtractions. Oh, I ain't stored it yet. So it's kept what it was there before. So 0, oh right, so it's definitely done the OC, because we said that 0 was add, 1 is subtract. So what it's, yeah, it's saying, we're running across the X, so it's working, right, so it's saying that Y should be subtract. So there we go. So it's worked it out it's worked it out right. Y is subtract. So we need to see, right, so if we're running through X, this is it here. So it's 89AO. There. So that's where it's going to start running through it. So I'm just going to, there we go, skip to it. So now this is where it should do the subtract. So we load E1, which has got OC, and in it with O1. That ain't right. That isn't right. That's why it's adding it. Have we got our masks wrong? Draw. Let's go to the top. So is X right? X1 is greater than X2. X1 is greater than X2, so therefore we're going to be subtracting on the X. So that's fine. That's fine. X1 is less than X2, so that's right here. Okay.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, hello by 64. Thanks for following. We're trying to figure out why my logic ain't working. Right. Hello. So this is relating to X, and we said X is that one there. Right. So we're saying that X. Right, I need to do that because it's only relating to X, that is. Now, this one here is relating to Y. So I need to preserve what we've already worked out, clear out. Okay, so we need to do that there. Clear out there, and then OR it. So this is saying if no, we just clear it out because that's X. We just clear it out. Then we work out Y. This is where I got it all wrong. Right, okay. So X on Y is that one. So if X2 is greater than X1, X on Y needs to be 1. So therefore I need to get rid of, clear out that. And OR it. So this one we need to clear it. Yeah, that looks okay. But we keep the Y's preserved. And then for the Y's, so the Y's are bit 2 and 0. So the Y's, we need to bit 2 and bit 0. So we need to clear out those, but keep those. So this is going to be 1 there and 1 there. If Y is greater, Y1 is greater than Y2. If it's the other way round, we need to do that. Okay. I think that's what was wrong with my logic. Oh, it's done it again. I'm going to have to spend some serious time on this program, I think. Right. So 150, draw 10, comma, comma 190 to 150, comma 10. That's the way we was going. That's the way we was going. Run. Ah! Get in there. Get in there. Get in there. Get in there. Let's do the other one. So 10, 190 to 190, 10. So that's the even slope. So that was working. 170, draw 10, 190 to 300, 10. There we go. There we go. There we go. I'm happy. So we're doing that way, we're doing that way, we're doing that way. So they're adds, and we're doing that way and that way. So they're minuses for. So we're doing additions of y. Right, so this one, these two are additions of y and additions of x. Yeah? Same with these two, additions of y and additions of x, but there's differences. We drew on the x-axis as here we drew on the y-axis. Here is subtracting on the x and subtracting on the y, on the x-axis. This one is subtracting on the x and subtracting on the y-axis. This one is the even Stevens. And now this is the combination of subtracting on the x but adding to y, subtracting on x. No, this is subtracting on y, adding on x, subtracting on y, adding on x. So what we need to do is just do a couple from here that does that. And then that's all 4 scenarios done. Okay. So 180. So we're going to draw, and we're going to have x at 250, y 22. So we're going to make x come down but make y go up. So we'll make x 50, comma y 150. Right, run. Yes! Oh! That's it. That's all 4 scenarios. That's all 4 combinations. And it's fast as well. It's fast compared to what we had before. 190. Draw 250, 20, 2, 20, oh, I can't do 250, can I? $190, 20 to 20, 190. That should be. Yep. Right. So the last one, 250, 20 to 20, 190. Yeah, I'm happy with that. That is doing all the different ways. That is doing all the different ways. Yee! Excellent. So let's close that down. Let's add another comment into here. What's today's date? 29th. There we go. Now the reason I've done that is because the draw is the backbone of everything we're going to do. When we do circles, we're literally going to be drawing lines that represents a circle. Same with the polygon, they're just going to be lines. The box function is just 4 lines, and so the draw line function has to be as quick as possible. And so we've just made it far quicker than it was before. I mean, we can put the old one back in to have a comparison if we wanted to. Do I really want to? No, not going backwards, going forwards. So the next function we'll try and tackle is circle. Let's see if we can try and tackle the circle function. Now I know I use basic commands in there, and so we'll do it using the basic commands first. But that's only working out the angle and where the point is. The drawing we'll use our thing, and then we'll try and see if we can convert it to machine code to work out all that angly stuff, which I'm not looking forward to. Or I might just chicken out and do box, triangle, and a few other commands. We'll see. Right. Thank you very much, guys, for following me, for those new followers, and for watching me struggle. We've now made it that it's now still a cartridge system, because we're now no longer doing any self-modifying code. We're using clever logic to run different routines as and when we need to. So yes, is there anyone around? Anyone around? There's Proton on. So what I'll say is, I'll see if the other half allows me to have another stream before New Year's Eve. If not, have a good New Year, and I will see you in the new year bright and early with season 2, because if I don't do another stream before New Year, this is the last stream in season 1, and season 2 will start. So happy New Year, guys. Thank you very much. Don't get too wasted, and I'll see you guys on Discord. Take care. Have fun. Let's raid Proton. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.